First we use the substitution method. So we select x squared as u and we differentiate both sides by x, so we get 2x, and we rearrange the formula here, so we have x dx equal as half du. So now we are going to substitute at the problem. So for the x dx we substitute half du, and we have square root here, and 1 minus, for the x squared we substitute u. Now we are going to rearrange the integration. Half is a coefficient, so we can write half outside the integration mark, and here you have du over 1 minus u. So purpose of integrating, so we need to rewrite the square root sign as like this, 1 minus u minus half du. So now we can use the formula xn dx equal x to the power n plus 1 over n plus 1 here. We can apply the rule, so we get 1 minus u minus half plus 1 over minus half plus 1. Again we have to divide by minus 1, that means the coefficient coefficient of the variable. Here we have minus 1, so we have to divide by the coefficient. Now you have half 1 minus u half over half, so this half cancel for this half. Now you have square root 1 minus u, but we can't write the answer by using u because u is the selected as variable, so our final answer should be in x. So the final answer is minus minus here also minus, so minus square root 1 minus x squared. Our next method is that also a substitution, but we use here x as sine theta. So differentiate dx by d theta, you got cos theta, so dx equal cos theta d theta. Again we are going to substitute here, so for x we substitute sine theta, and for dx we can write cos theta d theta, and inside the square root we have 1 minus sine square theta. So now we simplify this integral further. We have sine theta cos theta at the numerator, and here we have cos square theta, 1 minus sine square theta cos square theta, sine theta cos theta d theta, and the square root of cos square theta is cos theta. Now we can cancel cos theta to cos theta, so here sine theta d theta. The integration of sine theta is minus cos theta, and here also we can't write the answer using the theta, so we have to substitute x. So for that we can use a triangle. Here sine theta is equal x, so theta here, opposite is x, hypotenuse is 1, so the adjacent should be x1 minus x square root. So the cos theta is 1 minus square root 1 minus x squared. Our next method is very straightforward one, but this will be little bit difficult to understand. Anyway, I will try to explain this simple as possible. We can write x dx as half dx squared over 1 minus x squared. So how you can write x dx as half dx squared? This is happen because of when we differentiate dx squared by dx, we have 2x. So we can write half dx squared as x dx. This is important result here. So we substitute directly to the integral. So this is half dx squared over 1 minus x squared. So now our integral subject is x squared. So we can directly write answer here. So we can write this is as 1 minus x squared minus half plus 1 divided by minus half plus 1 and 1 over minus 1, because the coefficient we have to divide by the coefficient of the x. Here this is act as, say, y, this is as y. So this is like dy over square root 1 minus y. So we can directly apply the rule. That's why we are writing 1 minus x squared minus half plus 1 over minus half plus 1. So we simplify this one further. 1 minus x squared half over half into minus 1. So this half and this half cancelled. So final answer is minus square root 1 minus x squared. Put to see here. Our next method is we use u as square root 1 minus x squared. So this is we can say this is substitution method. Also we can say we have selected suitable function to differentiate, and by using that derivative we rearrange the integration. So in both way we can do the question. So we differentiate this one, du over dx equal, this is half, so half 1 minus x squared half minus 1 into minus 2x. So it's half cancel. Here you have minus and x. This is square root 1 minus x squared. Now we can write minus du as x over 1 minus x squared dx. This is similar to the what we got for the integration. So we put integration mark at the both sides, and we can write this part as I of the integral. So it is equal to minus du, so you get minus u plus, we can put c here. So what is minus u is square root 1 minus x square plus c. Here c is an constant. Now we use u as 1 minus x squared and differentiate this part, du over dx equal minus 2x. So minus du over 2 equals x dx. So we substitute at the integral. So x, for the x dx we can write minus du over 2, and you have square root here. This you can write u. So I equals minus half square root du over square root u. This is u minus half du. Now you can integrate u minus half plus 1 over minus half plus 1. So this one and this one cancelled. Now you have minus square root u. Again we have to write the answer by using x, so we have to write 1 minus x squared plus c.